Now we have a few math functions like square root, like rounding functions, and absolute. We also have power. Okay, so each of these have a special way to be used in Java. Basically what you need to do is to use math.sqrt, then for example let's say 25, and this would basically give you the result of the square root of 25. What we're doing here is basically we're telling Java, go to the file that is called math, and from that file there is a function. We'll be covering what functions are later on, but basically just use this thing from the math file and take this input and apply it on it and give me whatever result comes back. So let's try this here. Let's do system.out.println. And as you can see, the output is 5 and it's a double. Why did we assume that it's a double? Because we have a decimal place. Now let's say math.pow 52. This function basically takes the second input and uses it as a power for the first one. So the result would be 5 to the second, which is simply 25. Okay, now to the absolute. Let's say 25 minus 99. The result should be negative, but using the absolute we remove the negative sign and we just show the positive result. Now for the rounding functions we have 3 different functions. We have floor, ceil, and round. Floor basically rounds down towards the floor. Ceil rounds up, and round rounds normally as you would in any equation that you would solve. So let's do system.out.println math.floor 3.9999. This would be a 3. Let's do the same with ceil, but instead of 3.99 do 3.1111 or 3.00001, and this should give us a 4, as you can see here. So as I mentioned, floor rounds down, so no matter what's after the decimal point, it will push it up to the next integer. For the ceil, no matter what is after the decimal point, it would push it up towards the next integer. Floor would push it down, ceil would push it up. Now let's try the final one, which is round, and do 3.6 and 3.4. Let's just add some strings just to make things clear. and this is as of 25 minus 99. Then we have floor of 3.999, ceiling of 3. Now let's run the code and see the output. As you can see, round 3.6 gave us what we would normally expect from a rounding function. It rounded it up because it's closer to the next integer. And in the second case, when it was 3.4, it rounded it down because it's closer to the previous integer.